Dear Professor, I would like to submit my homework one shop number 4 about pneumatic system work signal follow diagram by microcontroller to control the A plus B plus A minus and B minus. In this tag, we can use the cylinder. The compares the limit switch and the impulse value, and use the switch button or push switch button or switch, and use the microcontroller use the Arduino. As shown in the chart, here are two components for control system. One is the double action pneumatic cylinder. The double action cylinder is a cylinder that uses a working fluid to alternating apply force to both sides of the piston. This allows the cylinder to extend and retract in a push-pull motion. The control system made up of 2 minus or 3 minus or 4 minus wave position value is required to achieve the desired movement. In this tag, we can use 2 cylinders. One is cylinder A, one is cylinder B. The other component is 5 two-way impulse value, or the solenoid value. For the 5 two-way impulse value, the pneumatic value is controlled by the applying respiratory point pressures at connection 1-4 is 1-4, and connecting 1-2 is 1-2. The value's operating position remains until an opposite signal is received by the value. We can use 2. For the third component is 3 two-way roller level value, or the micro limit switch, like this. For the roller level value, it's normally closed, often used to limit the position. The roller level value is operated by pressing on the level. The follow passes through from 1 to 2. After releasing the level, the value returns to the initial position through the use or the return spring. In this tag, we can use for the limit switches. Two switches in cylinder A, and 2 is in the 2 are in the cylinder B. The fourth component is 3-way value with push button. In the pneumatic system, we can use this. In this task, we can use the press switch. For the push button, it's also because it is used to start, normally open, Pressing the push button operates the value. When we press the button, the flow passes fr- freely from 1 to 2. 1 to 2. Releasing the push button allows the value to return to its starting position through use of a return spring. We need one button or one switch. The fifth component is the one-way follow control value. It's made up of a sorrow value and a check value. The check value stops the follow from passing in a certain direction. The follow then passes through the sorrow value. And the last component is air compressor. The compressor is a supply provides the needed compressed air. It contains a pressure control value that can be adjusted to output the desired operating pressure. Next, I will introduce the principle of cylinder movements. When we press the start switch, the cylinder A's air steam began work. From A0 move to A1 it's A plus motion. When the air steam arrived in the A1 position, the air steam returned to the A0 position. Oh, no. Oh, sorry. When the air steam arrived in the A1 position, the air steam of cylinder B is worked from B0 move to B1. It's B plus. When the air steam arrived in the B1 position, the air steam of cylinder A will return to A0 from A1 position. It's A minus. When the air steam of cylinder A arrived in the A0 position, the air steam of the cylinder B will return to B0 from B1 position. It's B minus motion. In the end, we can say air steam of cylinder A do A plus motion. The B0 impulse value connect with the left of the lunar level value, and the work done again and again. Like this is the step-by-step motion. The step 1 is start. Before the start, the cylinder A and the cylinder B is not work. But when we start again, the A minus motion is working. The air stream move from the A1, A0 move to A1 position is the cylinder B not work. And when the air stream arrived in A1, okay, the cylinder B's air stream move from the B0 position to B1 position. It's B minus, B plus, and the cylinder A not change. When the airstream arrived in B1 position, the cylinder A's airstream return to A1 from return to A0 from the A1 position is A minus. And when the airstream of cylinder A arrived in A1, okay, the cylinder B's airstream return to B0 position from B1 position. It's B minus. And when A plus, B plus, A minus, and B minus is completed this work and become the same as the before start and return the initial position. Sorry. In here, we can use the electric system to control the pneumatic work. We can use the limit switch, okay, and in the diagram of electric pneumatic system by the float same wall, we can say when we press the start and this is working and connect the Y1. The Y1 is working and the A plus motion is begin. And when the airstream arrived in the A1 position, the switch is closed and the Y3 is working. Y3 in here and the B plus motion is working. When the airstream arrived in B1 position, the B1 switch is closed and the Y2 is working. Y2 in here. Y2 is working. The A minus is working. The airstream return to A0 position from A1 position. When the airstream of cylinder A arrives in A0 position, it's closed and the Y4 is working. Y4 in here. Y4 is working. The airstream of cylinder B will return to B0 position from B1. And we can press the start switch and the control will work again. In the control, because I will use the Arduino control the pneumatic system. Because we use the controller. The controller is the Arduino. I will write a program use the C++ language to control the pneumatic system. First, we can include the PLC nib. The nib will the PLC neighbor. The neighbor will we can download from the Arduino or the PLC website and copy this to the neighbor of Arduino and set the start switch connect the 12 pins. The A1 the A0 limit switch, A1 limit switch, and the B0 limit switch and the B1 limit switch connect the 8, 9, 10, 11 pins of Arduino board. And the outputs will int the Y1, Y2, Y3, Y4 connect the 7, 6, 5, 4 pins of the Arduino. And in the board setup, we can pin mode the start button, the A1, A0, A0, A1, B0, B1, or are inputs, and the Y1, Y2, Y3, Y4 are outputs. And in the void loop, we can control the A plus, B plus, A minus, and B minus. We can tune the start ability the B1 here start B1 and dot the Y1 is working. It's A plus, and the A1 is working, the dot Y3 working, it's B plus, and B1 is okay, the Y2 is working, it's I minus, and when arrived the A0 define this and dot Y4, the Y4 is working, it's the B minus. Okay, this is all the Arduino control codes. Because the Arduino supplies the 5 volts power, but all the physical pneumatic system is 24 volts. So we can use the switching power supply. The switching power supplies is switched model power supplies. Short title as SMPS is an electric power supply that incorporates a switching regulator to convert electrical power efficiently, converts AC current into DC current, so it can be used by the device. And another, we can use the four-way relay. The relay is an electric switch controlled by an electric magnet. This electric magnet can operate in either AC or DC systems, allowing the relay to control the flow of current in various applications. For a switching device, the current circuit that operates with no power signals It enables a no-power supply uh, circuit to switch on or regulate a high-power supply circuit without integrating it with the same circuit or electric appliance. For the for the channel rail module is a convenient board that can control high voltage and high current nodes such as motor, solenoid valves, lamps, and AC nodes. It oh sorry. It's It's designed to interface with microcontrollers such as Arduino, PLC, and so on. The minor the middle terminal is the common terminal connected to the power source or node. The left terminal is the normally closed. It's called NC. Contact that connects to the device being controlled, and the right uh, the right terminal is the normally open, called NO. Contact that connects to the device being controlled. And here have 4 pins, in 1, in 2, in 3, in 4. Because this relay is 4-way, we can use in 1, in 2, in 3, in 4 connect to the Arduino 4 pins. And this is the VCC is power pin, and this is a ground pin. And I can see here have 2 pins, just another VCC and the GD VCC. For the VCC, this is the power selection jumper, and this GD VCC is backup power pin for the relay module. This is the A plus B plus A minus and B minus control by use the PLC. Just introduce begin the Y1 work and A plus. Y3 work is B plus, and the Y2 work is A minus. The Y4 work is B minus. Like this is the simulation in the Flood same software. You can say A plus, B plus, and again A minus and B minus. In the electric system controlled by electronic is this A, B. Let me say again. A minus. Oh, sorry. A plus. It's A plus, B plus, and A minus, B minus. It's okay. Next, I will show the video by microcontroller Arduino. I let me say again slowly. A plus B. Oh, sorry. Its speed is so fast. I plus I minus I B plus B minus. The speed maybe it's so fast. Again. Okay, this is our introduction of homework one shot. Number 4 about pneumatic system work single follow diagram by microcontroller. Thank you, sir.